structures, but it's not a very specific cycle like sinusoidal signal. You have sine signal, cosine signal, those are called as sinusoidal signals. There, the signal is generated using some mathematical function like cos theta, sine theta, sine 0, 1, 2, 3. In place of theta, you enter all values. Very nice sinusoidal signal you get, but it is not like that. That is exactly periodic signal. This is quasi-periodic signal, not exactly like a cycle, but there are some cycling from here to here. I can say that. Should I not touch this? Here to here, there is one cycle, second cycle, third cycle, fourth cycle. You can observe that. But here also cycles. This is semi-vowel. Cycle structure is different. So how human beings produce voice? We are producing voice since 30 years, 40 years, isn't it? How do we produce voice? Any idea? Any way that you have understood, you can tell. How do we produce voice? Normally, before producing a voice, we inhale air. Take air inside. Normally, who are singers, they experience it. Normal speaking, we don't experience, but while singing, you can very easily observe that they are inhaling air. So that air will be there in your lungs, and that air will come out through your mouth with certain modulations on the way. That will create a speech. Modulation happens at 2-3 places mainly. One place is at your throat. We have muscular components called as vocal folds. Those vocal folds keep on vibrating. They close, they open. They close, they open. Whenever they open, some air enters into your mouth. Whenever they close, that air stops. So this creates a chunk of air. Chunk means a small piece of air. So that air enters into your mouth. And in your mouth, you have some organs called as articulatory organs. We have lips, we have tongue, we have jaws, we have velum, a small bell kind of thing which is dangling at your throat. So all these articulatory organs move in a specific manner to produce something specific. That radiates out of your mouth, your lips, and it becomes a speech. We will see that little later. You will come to know that. But entire mechanism is like that. Air in the first you take air inside, that will be there in the lungs. Then it tries to come out. So whenever it tries to come out, it puts certain threshold on that vocal folds. Whenever threshold is very high, they open. Some part of air comes out. Threshold drops. Then again they close. Again air tries to come out. Threshold is built. Again vocal folds open. Some air comes. Again threshold drops. They close. Likewise, opening and closing of vocal folds get some air into mouth. In the mouth, articulatory organs move in a specific manner. They create certain sound, specific sound, which we call as phonemes. Is one phoneme, is one phoneme, a. You're seeing how my mouth changes. So all those phonemes are generated and radiated or sent out of my lips. So this way, the voice in case of human beings is produced. It's a very scientific process, very systematically trained process. If we do not have training, then we cannot speak. How do we get training? What's the basic means of training of speaking?
Observation.
Yes, observation through ears and through eyes.
Yes.
Now, small children hear many things through their ears. You might have seen if you have small children at your home, first they imitate only one word. They try to say that word and they see parents' face. Am I pronouncing it correct or not? And many times they pronounce something in a different manner. They are not comfortable with it. Then they keep on learning that. They keep on learning that. So there are some born deafs. Deafs means who cannot hear. Born deafs, will they be able to speak? Have you observed? Yes. Born deafs, will they be able to speak?
No, sir. Most of
They
them.
will not be able to speak
Most
because training is not there. So it's a systematic training phase of years together that makes us speak. Again, not only training, we have to have other skills also. That's what some of us will become very good speakers. some of us will not be able to speak. So your mind also should work, your vocabulary should be very strong, you should be reading more, all those things are there. So this is how the speech is produced. And how do we perceive speech once somebody speaks? We understand that, isn't it? How do we understand it? How do we perceive it? So this slide tells about that. This is the ear. Inside ear there is one drum which we call as ear drum. Thin membrane kind of a thing. Speech, once I am speaking, it travels, it broadcasts everywhere in the form of some signal. That signals are nothing but pressure waveforms. Those pressure waveforms hit your ear, and that diaphragm which is inside a membrane kind of a thing, it vibrates. It vibrates, and that vibration is passed to, there is one organ inside your inner ear called as cochlea. Cochlea is this kind, spiral structure object, and inside this there will be some liquid. This liquid and the skin of this cochlea is sensitive to different frequency components of the vibration. Any EC person is here? Okay. So then we can understand frequency components. Frequency components, cycles. Let's not worry much about that. Don't worry about it. This vibration should be sensed. Vibration of this membrane should be sensed. Then only we will be able to decide what has been heard. So, different regions of this cochlea are responsible for different frequency components. Say, for example, this senses 200 hertz, this region senses 400 hertz, 600 hertz, 800 hertz, 20,000 hertz, this region. That vibration is transformed to the liquid which is inside this cochlea, and this is directly connected to auditory nerve, which will go to brain. Brain will finally decide what are the frequency components available in the vibration that I have sensed. Those frequency components will finally decide which phoneme is spoken. All those phonemes are put together, concatenated, then which word is spoken. So all these words are put together, which sentence is spoken, then in which language, then we understand what has been spoken. So all these are the activities which happen once we hear a speech. Fine. So what are the frequency components in normal human being speech? And whenever I ask some questions, I will not ask any new questions. These are the questions which already you have come across during your high schools, primary schools, even not in colleges, high schools. So what are the frequency components in the human voice? Forgotten? 300 hertz to 3.3 kilohertz. So that is engineering knowledge, engineering electronics, second year knowledge. But I'm talking about high school knowledge.
Below 10, 20 hertz.
20 hertz to 20,000 hertz. 20. Audio range, but I will come to that point. You have some frequency components contributing to what we have spoken. Means whether I have spoken E, R. That is, as Sir said, it's up to 3.5 kilohertz or 4 kilohertz. But how we have spoken, what was the intention, intonation, who is speaking, is he a male or a she, female, what age, all this information we call as paralinguistic information. The paralinguistic information is in the higher frequency components, probably till 20 kilohertz, 20,000 hertz. So normal audio range, what human beings process is 20 hertz to 20,000 hertz, 20 kilohertz. So cochlear membrane recognizes, is designed in such a way that it recognizes all these frequency components. Then finally brain takes a decision, what has been spoken. We will come to that later, a little after 2-3 slides. But this we need to understand how we perceive speech. So this is the enlarged version of same cochlea. It is up to 20,000 hertz. This is called as a speech chain. Normally, person speaks. Part of it goes for feedback to his own mind. That's what sometimes whenever we speak wrong, we say sorry, and we correct it. Then it goes to the acoustic waveform. It reaches listeners yes, then so many things will happen and brain takes a decision. For that, one more interesting input is observation. We also observe through our eyes. Then we will be able to understand what is the mood of the person, how is he speaking, is he angry, very cool, all these kind of things. So two, three parameters together will help us to understand what we are speaking. Fine. One more next slide probably is understand. Here. See, this is a listener, this is a speaker. So message, whenever I want to speak, what I have to do, first I have to decide what I want to convey. After that, I have to choose a language. Should I use English, Kannada, Hindi, Marathi? That's a choice of language.
Yeah, in this, sorry,
No
I just found out.
Yes, sir.
So we are saying about this building contents under certain frequency, or you said just now.
Cochlear.
And this has got something to do with the extracting the speech
Features
rather than the speech itself.
Yes.
What exactly was those parameters you were talking about? What exactly is that?
Frequency components are you talking about?
There's some from when frequency we know.
No,
When we
frequency.
are extracting the feature of a speech.
Yes, I'll tell.
Yeah, we are
Frequency
extracting
is
the
a
parameter whether you are referring.
correct. Frequency is a very basic understanding which we can get from the speech signal.
Yes.
But that only is not sufficient
No, that's
to
what
decide.
I'm talking about the features.
Yes, those features are we have pitch is one feature.
Yes.
And we have an intensity is another feature. We have MFCCs, you might have heard, well frequency capsule coefficients. LPCCs are the linear predictive coefficients. Those are all derivatives
Three
of
are sufficient, sir, to extract the speech.
many people are now going for many features. And sometimes it is not possible for us to extract the relevant features because we don't know what is the relevant feature. In that case, now
Ones are using only three.
yes, and now what we are doing is entire speech signal of its one of its representations give us input to some CNN, convolution neural network. It does so many mathematical operations on that signal and it extracts some features finally, which we cannot name them, but probably they represent the speech signal in a better way than only frequency components, than only intensity components. So that way. Before this advent of neural networks, we had extracted certain features based on our understanding. These are called handcrafted features. But now, machines, artificial intelligence, that's doing all activity. Only give input and see the output. So we
Application like mobile phone, which is existing for almost 2 decades.
Yes.
What is being used is only three, and they are not altered that.
yes.
They are not altered so far.
Correct. That's what there is no big revolution in that audio part of the mobile
Audio
phone.
part, there is no revolution.
There is no revolution, only in
So it
interface.
is satisfactory.
It's satisfactory because even in human beings also we have to hear and understand the things. If we do that, the job is done there. So then I have to after choosing a language I have to decide which words will represent what concept. Then I have to make language, knowledge, then grammar of the language. Then I have to make a sentence. Then I have to instruct neuro impulses. My mind should instruct my articulatory organs in what way they have to move to produce those sound units. Then something in the form of speech comes out. That's from the speaker's point of view. Listeners, speech perception system, speech to nervous impulse. I told from cochlea it goes to nerve. Then message comprehension or message decoding happens in the brain. Then we understand what has been heard. The same thing, lungs, these are open folds, open whenever a threshold crosses a certain limit. Then it comes, this is a velum, it's a oral cavity, it comes here. Whenever this velum is, as I said, it's a dangling kind of bell kind of a thing which is at your throat. Sometimes it closes your oral cavity, so the air coming out will come through nasal cavity. Nasal sounds we produce, na, ya, na, ma, these kind of sounds. Whenever it closes here, then oral cavity is open and oral sounds are produced like a, e, k, ch, d, all these things. Fine. Already we are using this, don't worry much about that, just I am putting them in some formal understanding. This is also the same. This is ENC kind of a thing, frequency and time domain representation, how do we do that? So normally in case of machines, once we do this, noise, white noise, general random noise, it represents air that's coming in. Then we have some periodic impulses. This periodic impulses represent opening and closing of vocal folds. That's periodic in nature. So both of them with some gain, whether we have to make the signal strength or whatever, this one. Then it comes to filter. Filter acts as your oral cavity. Oral cavity, it's a response. Actually, it is a response to the stimulus. These things are stimuli. To this stimuli, in what way this filter responds, in what way our articulatory organs move, that decides what is coming out as a speech. In digital domain, speech is manufactured or not manufactured, speech is produced this way. Fine. So I was talking about excitation. Excitation is stimulus. How do you give stimulus to our oral cavity? That decides what speech comes out. So we have one voiced excitation. We are going a little bit into the technical details. Don't worry. In a very simple term, superficial way, I am discussing that. Whenever your vocal folds vibrate, at that time you produce some sound. That is called as voiced excitation. All those sounds produced are called as voiced sounds. Without vibrating vocal folds, also we can produce some sound units. Those are called as unvoiced sounds, unvoiced excitation. All vowels are voiced sounds. You can hold your throat and make that sound. That vibration is very fast. I don't know whether you'll be able to sense that or not. But whenever you produce some sound without vibrations, you'll be able to understand that there is no vibration. Like uh, is a fricative. Once I say is added to that, vibration will be there. Only consonant is there's a change. So all sounds you produce by vibration of the vocal folds, these are voiced sounds. Without vibration, unvoiced sounds. Last one. And totally the airflow cuts. Those are called as plosives or stops. Majority of the consonants are of that kind. K, ch, t. These are that kind. Again, there are certain differences. You will see that later. Based on that, these are the classification of speech sounds. Speech is a collection of phonemes. Phoneme is a sound unit, basic sound unit. So we have vowels. In vowels, we have front vowel, mid vowel, back vowel. We have diphthongs. Diphthongs are combination of more than one vowels. I. I means it's a combination of A and A and E. A and I. Ow. A and O. Fine. So those kind of things are called as diphthongs. Then we have semi-vowels, as I was telling here, all those things. Then we have stops, kachadadaba or gajadadaba. Gajadadaba or voiced. Voiced means while pronouncing them, vocal folds vibrate. While pronouncing kachadadaba, vocal folds do not vibrate, unvoiced. Then we have nasal sounds. We have fricatives. Fricatives were these kind of sound units. And we have whispers, whisper sound. We have artifacts, chirp, these kind of things. So this is general classification of all phonemes that we pronounce normally. A number of phonemes any language uses is limited to some 45-50. Any language you take in this world, these 40-50 phonemes only, we use them in a different manner. Different words are different, but phonemes are same. In English, words are different, Kannada words are different. But the sound units, what we use, they are same. The, the is there in Kannada also. Name, name is there in Kannada, ma is there in Kannada, but we use it in English. Fine. So phonemes are more or less same in all languages. There are some rare phonemes. Totally, there are 110 phonemes, but 50, around 50 are regularly used in any program, any communication language. But remaining 50-60 are rare phonemes, which are only for certain languages. We don't repeatedly use them. We were taking the front, central, front, mid, and back vowels. So vowels, pronunciation of vowels depends upon where your tongue hum happens. Whenever I say e, tongue will make a hump means speed filter kind of a shape. And if it is made at the front part of your tongue, those are called front vowels. E, A, these are all front vowels. And central vowels or mid vowels, tongue hump happens at the middle of the tongue portion, middle of your tongue. Then back side, if hump happens, it's oo, all these vowels. And whether this hump is very high, mid or low, that also will decide. If it's very high, it is E. If it is if it's mid, it is A. I'm talking about its pronunciation. It is E, but pronunciation is A. Pen, E, P-E-N, A. Pronunciation is A. So that way, vowels are divided based on tongue hump. Right? So if you have any questions in between, you have to ask. Otherwise, it will be very boring.
So I have very fundamental questions that just troubling me.
No problem.
Yes. It's whenever we say human vocal cords, which is a plural,
Human vocal cords.
we never say it's a chord. The vocal cords, each one of them will have birth.
Vocal folds you're talking
The,
about?
the chords, the fundamental, primary frequencies.
Those are two, sir.
Only two, right?
Only two.
The female
No,
and
it is-
male both will have only
Yes, only two. It is a muscular
Yes.
component.
It's not three.
No, it's not three.
Oh,
So muscular component.
Yeah.
Maybe certain bifurcations are there in the
But it is
basically
predominantly it's two.
two.
Only. Everybody is having only
Yes,
two.
one at the left side, one at the right side.
Right.
Whenever they close, it stops airflow.
Right.
Whenever it opens, the airflow comes.
Okay.
If it is not able to completely close,
Okay.
then some air always keeps coming. That leads to three keywords.
Which means there is only possibility is only the harmonics of that.
Yes,
Nothing
yes,
else.
yes.
Nothing else.
Nothing else.
Only the harmonics.
Yes.
And the speech is produced.
That harmonics also will calculate that.
Okay.
Yes.
Right.
Right. So these are sir.
So go back to the previous question of the
Okay.
that real-time translation of the languages
Mm.
is said to be done. That's what you said. In the
No, it to be done in the sense 100% translation is not possible.
so what are these earbuds available, sir, in the market? Translation in earbuds, language translation earbuds.
No, that's not. The Bhashini, there is one central government scheme called as Bhashini. Bhashini's purpose is this only. All regional language translation should happen using machine learning tools. Earlier, what we used to do, we used to study their grammar, their structure, then we used to translate. But that's a very difficult task. Now, feed all Tamil speech, feed all Kannada speech. For this Tamil sentence, this is equivalent to Kannada. Whether the machine is able to learn that. That's what Bhashini people are doing now.
So
So
what's
if
happening in the earbuds, sir, now? How translation?
earbuds are not specifically used. Earbuds means in tourist place whenever we go, they give
go
some.
with the earbuds, whichever language they speak.
Yes.
Can be converted to our.
That is pre-recorded, sir. That is not translated. It's not translated. Say for example, you want to hear commentary about something in a tourist place in Malayalam.
Not that, sir.
Hmm.
Sir, to understand the foreign language,
Okay.
whenever they speak in some other
Okay,
language,
it's a spot
it has been
translation. It's a
translation.
spot translation. Yes, correct. That is spot translation. It will not be perfect.
It's used done by using AI.
It is done by using AI only, but it is not a perfect translation.
Okay.
It's not like Deepa Bastik's translation of Heartland. So some problems will be there, but it is communicating. Your idea I will get, but it's not. If you see grammar of the language, if you see words of the language, it's not a perfect
I
translation.
can help the sir.
Yes.
Sir, just you watch a Kannada movie with English subtitle. You understand the quality of the translation.
No, not that
No,
time.
no. The same thing will be translated to voice, I think. It's not that voice to voice. So there is something in between interface. If that interface goes fine, then output comes better. So still there's mapping required, what I understand.
Completely perfect translation is not.
Mapping is not there. sir.
AI is doing it.
Hmm.
AI is definitely translating. It's not perfect one. So this is something like I was talking about hump. So this is a tongue. It's a front hump. It's a back hump. Vowel production. There is a clear path for air to go out. So which is the first phoneme that children produce?
Ah, ma.
Phoneme I'm talking about. Immediately after taking birth, they start crying, isn't it? Ah. So vowels are very easy to produce. So some constriction should happen using tongues, and from the air cavity, air continuously flows out. So these are plosives. I said k, ch, d, wherever some stop happens. So we will see that also later. Here there is no air passage. Your tongue touches different portions of your mouth, so that whichever air is coming, it stops there. Consonants are produced. Fricatives, a whistle kind of a sound. Small aperture is left, not as big as this. A small aperture is left through which the air is passing. Then automatically a whistle kind of sound is produced. No questions, no. This is a very beautiful slide. I like this slide very much. You also will start liking this later. This is the organization of Devanagari script. This is the organization of Devanagari script and Devanagari phoneme sounds in a written form. Done around 2000 years back. 2000 years back. Who did that? This classification is Vargiya Vyanjana, all of us have studied, isn't it? Yes. Vargiya Vyanjana, Yaralagara, Vargiya, Kakaganga, Vargiya. Before that, before that we have E. This is only about Vargiya Vyanjana I'm talking. In Devanagari it was there earlier, Sanskrit, now Hindi. In Kannada also it is there. Hindi. Kannada also it is there. Who did that for the first time? Panini has done it. Panini's Vyakarana Shastra, yes, a book he has written. In that book it is done. Now, what's the beauty of this? I'll tell you. So this is Kavarga, this is Pavarga. Can anybody pronounce any one of these phonemes without closing your lips? Without closing your lips. But ventriculists do that. Ventriculists, you know that Matanadu, Bombay, they play with that. That they will do that. That is different.
And in Tavarga, we bite our tongue.
Ma, you cannot produce without closing your lips. Means, I was talking about stopping of air. That stopping of air should happen at the labial level, lip level. Then only you can say ma. Otherwise, it's not possible. Similarly, can you tell where that air stoppage happens once you're pronouncing Kavarga, ka, kha, ga, ga, nga?
Yes.
No,
It's a very big thing. Backside, where backside? All of them, all other things are backside only. All these are backside only.
Initially.
Stoppage of air happens at your velum position. We call it velar position. It's written here. You would have seen this also. At the place of velum, the stoppage of air happens. Then only you'll be able to say ka, kha, ga, kha, nga. Fine. And next is at the next level. Ka, cha, chavarga. Chavarga is little bit afterwards. That's called palatal region. Ta, ka, cha, ta. Again afterwards. It's called as alveolar region. Next is then ta, tha, da, dha, na. Stoppage of air should happen at the dental level. Dental level. You're at the lips level. This is one thing, one beauty about this. So see the organization. First velar, next palatal, next retroflex, next dental, next lip. In that way itself, these are organized. And coming to these two things, ka, kha. One is unaspirated, first one is unaspirated, we call it as alpa prana. Second one is aspirated mahaprana, ka, kha. Coming to this ga, kha. Ga is alpa prana, kha is mahaprana. But if you see these two things, if you have remembered my previous slides, these two are voiced sounds. Voiced sounds means those are produced by vibrating vocal folds. Without vibrating vocal folds, you cannot produce ga and kha. You will see that waveform later. But ka, kha, without vibration of the vocal folds, we can produce. So that is unvoiced. Unvoiced are put here, voiced are put here. What is the last one? Last one is Anunasika. We call it Anunasika. Anunasika. It's a nasal sound. In each varga, we have one nasal sound kept at the end. Voiced, unvoiced, velar constriction, labial constriction, This is the organization of phonemes which was given 2000 years ago. So the known phonemes we are using in all Indian languages. Which are different.
Origin of any language this way, it is this way.
No, but I did not get the answer to the question how ABCD are arranged.
Right, that's what.
No, I'm not demeaning any language.
Okay.
But how ABCD? What is the logic behind B comes after A?
Yes, that's
C comes after B. Till today, I did not get that.
Alright.
Only thing what I got
My
was
question was actually leading to that.
only reason might be is it was very rhythmic to say in KG schools A B C D E F G. No, still we are all following English. That's all fine. That's all fine. But this is a knowledge which we had 2000 years before, when acoustics was not known, or we think acoustic was not known at that time. Once